of people sent me emails that said something along the lines of they did their test, but when they were finished, i.e. when they came out of it, the counter was still going, or there was no verification that it saved. The good news is that even if it doesn't tell you, it has saved. Because the two people who sent, I went in and everything was there. So I'm pretty sure that's okay.
Is that normally how that program works?
Like, yeah, I don't know why it does. I think, yeah, Rosie's known. So it just never tells you. It just does it, right?
Okay.
Yeah. I think it wouldn't be that hard for them to just have a big, hey, you've now finished your test and we've got all your stuff. Some just to make you feel better.
Yeah.
But it does work. So don't worry about it. Were you one of those two people that sent me the email?
I was, because I got so nervous. I like kept saving it and I kept submitting it, and like the time just kept counting down, and I was like, what do I do? Just the moment you submit it like stops the time and it'll just like be done, and it kept going, and I'm like, oh, I think I broke it.
Oh, no, it's just being awkward. It seems to be that's just the way it does things. Okay. Aidan, did you have the same issue that you'd finished, but you didn't know if it saved your stuff?
Actually, I figured out what was going on with the histogram problem.
I did, yeah.
That was really confusing. So it was.
I just took that question out of everybody's homework and got it to rescore without it. It was just it just wasn't a good question, basically.
Well,
right?
Actually, it was just a question asking. So if you have a bimodal histogram in which there are two distinct parameters, it was assessing two parameters or something.
Yeah, and it was subtracting one from the other to get the next one. Yeah, that they could have made that a lot clearer in the way that they did the information, and I think it was just fairer to take the question out rather than have some of you get the points and some of you not really understanding.
Yeah, that wasn't. Yeah. Are you talking about? There was a question like that on the quiz. Did you say you took that off the quiz?
No, not that one. That one I thought was a little bit clearer. No, the one I took off was the homework question.
Okay. Will we be able to see the quiz and the questions we got wrong? I checked WebAssign this morning and I can't.
You won't see it until after I've checked. Once I've gone through it and regraded it, because I always rescore them, because WebAssign's very cruel. It's either 100% right or 100% wrong, and sometimes you're half right, so you should get at least half the points, and it doesn't. So that's once I've done that, once you see your score, that is your final what you get score. Otherwise, you'll take a look and you'll say, I only got 40% and freak out, and then after I grade it ends up being 80%, and you're saying, oh, I'm not too worried now. So it's better to wait until I fixed it so you don't get any shocks, because sometimes
I kept getting wrong that would like compare the differences between the cluster sample and the stratified sample or something like that.
Yeah. Well, one you ask everybody, and the other you don't need to. That's the easiest way to tell the difference. But too late now. Okay. Well, we got time, but we still should have how many people? Jeez. We're 4 people missing.
Did they drop the class or something?
No, I doubt it.
I almost dropped the class when WebAssign made me pay for the.
Oh, you didn't want to pay money?
Access.
Sorry about that.
No, I forgot to email Mesa about getting
help or whatever.
Yeah.
Gotcha. Keep talking.
Speaking of dropped classes, there was also a question on the homework or something that was talking. Well, actually, no, it was on the homework and on the quiz, but it was talking about when you have like a sample frame and you create that on one day, and then you're like, oh, next Monday I'm going to collect data. Well, people can drop the class between the present and the future. So I mean,
that's interesting. Yeah, I guess they could.
But dropouts wasn't a answer for some reason.
No, there must have been something a little bit more likely than that. Yeah, I'm saying people could have dropped out, but I'd have to check the choices. But there probably was something else in that list of things that which was more likely to be the case. I would have as I guess. Can't remember or recollect that question. Okay, let's get started, everyone. Hopefully, it's now all 3 people will turn up shortly. So, new section. Still from chapter 2, so we're getting chapter 2 finished today, and this is the stuff I was kind of last week thinking we might get to and we didn't. And it's really just more diagrams and charts, and what I've got here is a very basic version of the types of things where you can visualize your data, right? Put it in a format that would make it easier to see what's going on. Bar charts are very often used when your data is not numbers, like red, blue, green, old people, young people, anything that can be categorized without necessarily using numbers. And the thing that makes a bar chart different than a histogram is you put gaps between them. Oh, and there's 2 of the 3 people that are missing. And pie charts, very, very, well, not to use pie charts. Pie charts do get used a lot in books and diagrams and so on, but they are very, very hard to draw by hand. Nobody would really expect you to do it. But that's what a pie chart, so it might be, the pie chart is all high school students, and each one of these segments is the number of students in each category. So that might be your juniors and your sophomores and your seniors and so on, right? And the bigger the piece of pie, the more people that are in that particular group, right? Don't think we've done time series, but essentially a time series is where you measure maybe very often time. So it could be, days. So this may be day 1, day 2, day 3, day 4, day 5, day 6, something like that. And then you could measure the highest temperature in that day. So we call them time series. The x-axis is typically some kind of measurement of time, minutes, seconds, days, years. And vertical is something that you're measuring on those days or times. Could be temperature. Can you do one where you're over a 5-month period, you were weighing something and it increased in weight and then it started decreasing weight? You may or may not have seen a diagram that looks like this, but this is called a stem and leaf, and we'll show you today how you can make one. Here are 2 special diagrams, charts that you're going to see. There's one called a parental chart, which is just a version of a bar chart. A parental chart is where you put the things in order from smallest to biggest, or more commonly from biggest to smallest. And when you see it written like this, it's a parental chart. And there's another last diagram called a back-to-back stem and leaf. And a back-to-back stem and leaf is a bit like a stem and leaf, but instead of just having one group of data, you have 2 groups of data. So you can imagine this one here on the right might be males, and this one on the left might be females, and this is the weight of adult animals or something. So that's what we're going to deal with for today. We are going to look at things like how do you construct them, for the most part, but not all. You'll get web assigned to do them, at least the ones that are difficult, and to interpret them, right? What can you get from such a diagram? So let me jump right in and look at our bar charts, and in particular our parental charts. So quite a few of these questions take more reading than they do to do the question, right? You read the question, it takes about 3 minutes, and it takes you about 3 seconds to pick the answer. So the first couple are what type of data from the 4 choice would you use? and I'll let you figure them out yourself. You can read about them. Right, let's look at 3. It is costly in both time and money to go to college. Definitely is. Does it pay off? Right? Am I going to actually make any money out of this, or am I just going into debt for no good reason? And it depends on who you talk to and their circumstances. Because I know you might talk to people who said, yeah, I went to college and I'm still working at McDonald's. College didn't do me any good. And then you might know people, hopefully more of those, who have now got a pretty interesting career and hopefully are making pretty good money. So let's see if it pays off. So according to the Bureau of the Census, right, the government data, the answer is yes. You do actually make more money the more educated you are. The more educated you are, you can still do the jobs you could do before you were educated, but now can't you do other jobs now that you've got an education because you know more stuff, right? So that would be, again, the logic behind it, I would believe. So the average annual income in thousands of dollars of households headed by a person with a stated educational level. So if you go to a house and it's your mum or your dad, or your mum or your mum, whoever it is, whoever is the one that's making the money, sometimes it's both of you, but whoever's making the most, then this is where this data is coming from. If 9th grade was the highest level that you ever achieved, those people are making 24.8 thousand a year. That's their salary. They're making 41.4 thousand if they graduated from high school. So do you notice the difference between this number and that number is, even that is quite significant, isn't it? About 16,000 more money. If you move beyond high school, if you get an associate's degree, the average, right? So there's going to be people this is not true for, but for a lot of people it will, right? On average, it is true. Do you see you'll make about 15,000 more a year? If you go on to university and get a bachelor's, it's 82,000. If you get a master's degree, it's up to 100,000. And if you get a doctoral degree, it's now 121,000. And a doctoral degree doesn't just mean you're a doctor. And, you know, any of our professors who are doctor, we've got some in the sciences, right? There's a lot of doctors in there. Their average is also 121,000 between all those choices. So that took more time to read than the question. Make a bar chart showing the household income for each educational level. Now, do you see there's little spaces between the rectangles? That's what makes a bar chart, right? That's the main feature. Secondly, do you notice that the x-axis has 9th, high school, all the way up to doctorate, right? So all we need to do is basically look at these numbers and find out which one of these diagrams is actually using these numbers. So let's start at, if you never finished high school, you're going to make 24.8, right? 9th grade, 24.8. Okay, could be that one, right? Could be that one. It's definitely not the top left or the bottom right. Would you agree they don't work? Now, without getting into too much detail, do you notice that each number gets bigger than the one before? Can you see that step ladder going uphill? Doesn't that make sense that this is the right one? So it took me a lot longer to read that than it would have done to pick the bar chart. Great. All you do is say that one. So this one is saying make a Pareto chart. And it's all about catching fish and how much fish they catch. So flatfish, Pacific cod, whatever a sablefish is, and so on. I don't really mind what the fish are called. But it's a Pareto chart. And in a Pareto chart, you rearrange the bottom so that the biggest number goes first and the next most popular next and all the way down. So as I look at this, and you'll tell me if I screw up here, would you agree that, how do you turn this out? So it's the name, then the number, the name, then the number, the name, then the number. Okay, so Walleye Pollock, 71.9. Okay, Pollock is first, all of them. 71.9. Would you agree that the only one of them that's got the right number with the Walleye Pollock was that picture? And do you see that everybody in order of importance? So the most was Pollock, then this cod, then these two, and then finish with sablefish. Are you good with that?
Is it always largest to smallest, or does it ever go the other way?
Typically, when you see a Parental, it's always biggest to smallest. Technically, you could go the other way, but almost always it's biggest to smallest. Now, here we have a set of data to do with 5 areas and the number of spearheads. Okay, and they are saying make a Parental chart. Now, when I look at this chart, I don't actually even bother about looking at the numbers because the choices they give me, won't one of those charts look right? And if we work on the assumption that you should do biggest to smallest, would you agree it's that one? A histogram, biggest to smallest, Parental. Now, here is, I think, the only question that has a pie chart in it. Okay. And in this pie chart, each colored wedge represents one of those 5 areas. And it looks like it's quite difficult just to look at this picture, because it is. So I'm showing you how I'm going to decide which one of these 4 pictures is the same information that you get from this table. Right. So let's, for no particular reason, pick Shannon. Now, do you see how they've told you 33%, 33.7, 40.4, or 37? Do you see they're telling you 4 different numbers, but only one of them is the right percentage. So if I go up here and I look at Shannon, there was 30. Now, if I add everything up, that's 30, 45, 75, 85, 89. So I know that 30 divided by 89 and then converted into a percentage is about 33.7%. So 30 divided by the total, which was 89, then multiply that by 100 to get a percentage. And if you round it off, it's 33.7 and 33.7. Oh, by sheer luck, it was that one. So that's how I knew it was that one and not the others, because that's the only one where that's 33.7. Do you see that's too big? That's really big, and that's a little too little. Okay, we are looking for a Parental. Well, Parental should be biggest to smallest. Oh, darn it. They're all big to small, right? So I'm going to have to do a little bit more work on this one. And this one is about Aloha State in Hawaii, right? Aloha, Hawaii, right? And these are the horrible things that could happen to you. And these are the crime rates. So crime rates are very often done as a version of 100,000. So for every 100,000 in the population, 4.6 of you are going to get murdered. Oh, that's not good. Or 563 of you are going to have your car put into. Wow. House burglary. That's almost 1,000, isn't it? Almost 1,000. So 1,000 out of 100,000. Every year, you've got a 1 in 100 chance of your house being broken into in Aloha, Hawaii. That's not good. Evidently in Hawaii, they don't kill you, but they break into your house and steal your stuff. Right? That seems to be their thing. Probably in a place like New York, you probably get killed more often than they break into your house, but that's because of big apartments, right? And they're harder to get into. Maybe Hawaii's easy to break into, right? Everybody leaves their door open and, you know, whatever. Focus, Donald. Since that is the biggest number, right? And it was house burglary, don't I just need to find out which one has 947 on it? And guess what? I've now found it. It was that one. And then you can answer some other questions. There's a similar one I'm not going to do. Here is an example of a time series graph, right? Time period. Each one of these is a year because it's a 15-year period. And here is elevation. And the elevation of a lake surface, that's feet above ground level, varies depending on, you know, how much rain there was each year, right? Sometimes it goes up and next year it goes down. And this is one particular period, one particular place, I should say, over a 15-year period. And so it starts off at 2817 and it finishes at 2817. And then what does it do? It goes down and then it climbs up. So wouldn't I be looking for it goes down and then it climbs up? Are you happy? But that would be the picture without getting into too much detail. I'll show you how I dig that. 28 goes down, goes down, goes down, goes down even more, then gets bigger, then gets bigger. That makes sense? Yeah. You could check each number, but I think that would be it. And now we get, and I hate this question with a vengeance, because I did this one for practice to see if there was a quicker way of doing it, and there isn't. So we are going to make our own time series graph by measuring the age of, what is it, a kid? Of a boy as he gets older. So he starts off at 6 months, right, 0.5, and this is 8, and this is the kid's height in inches. So you go here to the left, you pick the 2 dot thing, and the first dot is half a year 26. So my best guess is a half is about here and 26 is about there. And then it goes 1,29. So there's 1, and I'm guesstimating 29 is there. You see, that's me done the first to the second. I'm then going to go over here and see if I did it even good. 0.5 to 27. Nope, that should have been 26. 1 to 29. Right, I got that one right. Close it off. And then you go back and you do it again. And you start here at 129 and you finish at 233, which is about here. And then you go over here and yep, I did that one right. And then you do it all over again. And you do here, that's 233 to 336, which is about here. And then you check it and it should be 233 to 336. Are you already getting bored watching me? Because I'm bored doing it. Can you imagine doing it all the way to the end? Right? 1 to 1, check it. 1 to 1, check it. 1 to 1, check it. And then you just hit submit and you'll be correct. So that is how you would use WebAssign to draw a time series. And I have a chat here. Rosie, did you write down there's something I can do here, or did you find a better way than the way I just did it?
Yeah, so when you were plotting the line segments, you don't have to like guess where the end is on the graph. You can just click on any point in the graph and then go to graph layers, click on line segment, whichever one you're working on, and then in the boxes where you put the X and Y coordinates, you can type the coordinate and it will just plot it automatically. You can choose if it's a closed or open dot.
Oh, so let me see if I can.
That's what I do. I just
right.
put points wherever and then fix it.
Fix it after the event. Right.
Yep.
So if I've got you correct, and I think I have, imagine I was going to do the next set of points, right? And I just randomly picked 2 places to put them. And then you go over here and you make sure that they are the right points. So this would be 336. And then you make the other one 439. And then, well, basically that's it, isn't it? Is that what you're saying, Rosie?
Yep.
Yeah.
That's it.
Right. So you don't even be too particular when you're doing it.
Just keep an eye on whether it's a open or closed dot, because since you
Ooh,
have
I
more
think
data points, it would need to be closed.
Yeah. I accidentally made one of them a little open one, didn't I? Okay. Oh, learned something. That's cool. Let's move to showing you by hand how to do what is called a stem and leaf diagram. Imagine I had some data, and I'm going to do it all jumbled up. I know this is taking me a little while to do this, but it kind of helps to see what I'm up to. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So I have 24 data points, and imagine these are the ages of students in a class, right? You draw a vertical line. It's called the stem, and in this case, the stem is going to represent times 10. What that means is that 1 doesn't mean 1, it means 10s. That means 20s, that means 30s, that means 40s, that means 50s, and that means 60s. And then you do a leaf, and my leaves are going to be almost all of leaves are times 1. And so what I now do is I go through my data and I put it into my stem and leaf. And it typically takes 2 steps. This is going to be the first go round. 17, space, 16, 25, leave a space, 37, 41, 39, so leave a space, 39, 14, 21, 27, 43, 45, 51, 31, 37, 26, I'm here now, 29, 31, 41, 11, 17, 19, 21, 33, and 62. Now, do you see how it's relatively quick to go through this? When I wanted 14, do you notice I only put 4 there, right? I didn't put 1, 4, right? How do I know that it's 14? Because it's part of this guy, right? 1 and 4 makes 14. Doesn't that 9 mean 39? Doesn't that 5 mean 45? In fact, when you do a stem and leaf, you should put a thing called a key. And the key, basically, you would say 1/7 means 17. And the reason why that is helpful and necessary is that in a different set of data, can you imagine this was 170, 160, 290. Imagine the data was like that. Wouldn't 1/7 mean 170, right? It would mean a different amount in different contexts, right? Now, I said this is a two-stage process because it's not actually considered in its best format right now. What do you think I might be doing here now? I got the guy, but what do you think I might do to change it a little bit so it's a little bit more informative?
Writing the leaves from smallest to largest.
That's it. So that's a 1, a 4, a 6, 2 7s, and a 9. And then it would be 2 1s, a 5, 6, 7, and then a 9. And then it was 2 1s again, a 3, 2 7s, and a 9. And then it would be 2 1s, a 3, and a 5, just a single 1 and a single 2. That with the key. Probably a heading like ages of students in class. Right, you put that package together. Doesn't that really tell you everything that you need to know about this class? Right. And if you take a stem and leaf and you turn it sideways, doesn't it kind of look like a histogram? So it's very often it's one of the things you do right at the start of your analysis. It might not be the thing that you put in the magazine or you publish, but it's something to get an idea of, you know, what it's like. So how does that type of question, and there's two versions of that. That's a single stem and leaf. That's one this is. How do you do questions like that in WebAssign? And the answer is you essentially do what I just did. It's just a little bit harder for me, especially, because I only have one good eye, and scanning is a killer for me, because I'll be in row 2 and then I'll go back, and when I look, I'm now in row 3, I scan very badly. But here we have a story, a piece of data. How long did cowboys really live? You know, if you watch Westerns, you think none of them live because they keep on having gunfights and getting killed. But evidently that's maybe not the normal life for a normal cowboy. Now, one of the ways in which they collected this data is in a book called The Last Cowboys, and you can get it in University New Mexico Press. And this book gives a thoughtful sociological study of cowboys in West Texas and southeastern New Mexico round about the year 1890. And this is a sample of 32 cowboys gave the following years of longevity. One of the ways you do that is you would go around old graveyards and you would just find the age that they died in, right? So as I scan through these data, the first thing I need to create, this is going to be where my stem and leaf data goes, right in here. One of the first things I need to find is, who is the smallest number? What was the youngest age that the cowboy died?
I see a 58.
Okay, I see a 52, but anybody under, anybody see a 40? You see a 27?
47.
47. Where is it?
Oh, it's
Last
the
one.
very last one on the third
Oh,
row.
gotcha. Right. So would you agree it's a bit like bidding? Nobody's bidding less than 40. Would you agree we got a 40? So I'm going to put 40 in, right? And I'm going to put 50s in, 60s in, 70s in, 80s in, and I'm assuming there's a 90. Hey, there's a cowboy. He lived, he was 93. Now, the next bit, I am not going to make any attempt to do this accurately, because even if I did, I'd screw up. I'm going to pretend that I went through this data. So I might do it for the first few, then I'm going to cheat. Oh, top row, this data here, right? So I might go 58 space 52, 68 space 86 space, right? Okay, I'm going to stop doing it realistically. Then pay no attention to this data. This is me randomly pretending that I did it right. Right. Can you pretend that was the real data, right? Just pretend, right? Now, is that going to be the correct answer? Is that the end of this table? No, what do I need to do to these numbers on the right-hand side? The leaves, as they're called. What will I do with
largest?
Right, so in this case, that's good, right? But in this case, won't I have to call it 0? Right, let's put a whole big space in here so I can make sure I don't rub them out. I'll do a 0, then I would do what, a 2, then I would do a 4, then I would do a 5, and finally I think I would do an 8. So that would take care of all of them. Oh, did I miss somebody? There's a 6, okay. There we go. And that would take care of all of them. Rub out that. Now the next one would be what, 5, 6, 6, 8. So I don't need to change too much here. In fact, this might be the way I would do it in real life, right? If I had my data. Would you agree that one's good? That one's good. Isn't this one almost good? Why do you need to put a single space between each of these digits? Why does WebAssign want that?
To separate the values.
Yeah, that's all. Just make it look pretty. Right, now if that was correct, you're done, right? Are you comfortable about how to create a stem and leaf then, even if I cheated with the data, right? Can you imagine doing the same again with all these? Right. Can you imagine we then had to do our next guy? And in this case, oops, let's rewind. I know there's 2 sets of data, but we're only going to do single stem and leaves. So that's actually not the next guy. And now that I've highlighted it. So in this set of data, you've got these numbers. There is a difference here. Do you notice that these numbers don't vary a lot? There's single digits, there's 10s, and there's 20s. Now to do single digits, you put a 0. To do 10s, you put a 1. And to do 20s, you put a 2. So if I wanted to do 7, you would just do 7. If I wanted to do 16, you would do 16. And if I wanted to do, I don't know, 22, you would do 22. Now, the first thing that makes this different from the last one, do you see that I've grouped the data so that there's 2 stems with 0, 2 stems with 1, and 2 stems with 2. And the reason that I'm going to do that is that you don't always do a single guy with a single value. If I did a stem and leaf and I did 0, 1, and 2, imagine that was all my stems were. Wouldn't I end up with data that would look like this? Wouldn't there be very little information, right? Because there's only 3 rows. So what you do is you split them into 2 zeros, 2 1s, and 2 2s. And in the first one, you do 0, 1, 2, 3, and 4. And in the second group, you do 5, 6, 7, 8s, and 9s. So in other words, The small ones and the big ones. The small teens and the big teens. The small 20s and the big 20s. Small is 20 to 24. Big 20s is 25 to 29. Does that kind of make sense, that it allows you to have a stem and leaf with a little bit more rows to it and therefore a little bit more information? So I'm now going to return back to that question and maybe do the data correctly, because there's not that many of them and I think I could probably get away with it. So the first number is 16. Does 16 go on the top one or the one underneath it? Where should I put 16? Top one or the one underneath it?
Can you share your screen, please?
No, I want to keep it a secret.
Please.
Oh, sugar and spice. Okay, there you go. Again, now the question will make a little bit more sense. We're doing the earlier period, right? So I'm only doing the first one, right? The earlier period. 16. Does it go in the top one or the bottom one?
Bottom one.
Right. Right. 10 to 15 goes in the top, 16 to 19 goes in the bottom. Right, the next number is 13, so I'm going to put it there. The next number is 14, so I'm putting it there. Next number is 15, I'm putting, oh, where does 15 go?
In the bottom one?
In the bottom one, yeah. Right, 10, 11, 12, 13, 14 goes in the top, that's the smaller guys. 15 to 19 goes in the bottom. Right, next one is 13, so that's back to being in the top. Next one is 16, that goes here. The next number is 23, that's in the top one of the two. 8, does 8 go here, the first one, or does 8 go here, the second one? Top or bottom for 8?
Bottom.
Bottom, agreed. And won't 7 also go in the bottom? And 22 goes here. And 19 go 22. Almost made a mistake there. 22 goes here. 19 goes here. 18 also goes here. The other 18 goes right next to it. 13 goes here. 17 goes here. 10 goes here. 20 goes here. Who else are we left with? 15 and goes here. Are we good with that? Right, wouldn't I then go through them again and put them in order? So that guy becomes 7 and 8. And this one is a 0. 3 3s, a 4 and a 5. And this one would go a 0 at the front. That's that guy taken care of. A 5 with 2 6s. And then it would go a 7, 2 8s and a 9. And the last one, you just switch places. Now, do you notice that this one is blank and that one is blank? Because there weren't any high 20s, at least none in this group, right? And there weren't any very low zeros. If you haven't done WebAssign before, anything that is red is variable. That means when Rosie comes to do this question, she won't get the same numbers as me.
I got a quick question.
Yes, Zach.
The second one, you put the 20 in there. Is that because you don't want it to overlap, or?
The second one, I put in 20.
Yeah, you put a 20 in there.
Oh, there is a 20, isn't there?
Yeah, I didn't know if you meant.
I think I just missed it.
Oh, okay.
There, it's there.
Okay.
Now, I better check that I didn't put that guy in the wrong place because I think that might be my scanning. Yeah.
Okay, I don't know if you
yeah.
put it in the wrong place or if that's the way it was
Nah,
supposed
I put it in the wrong place. I just stuck it in the box above and said the one below. Right. So I was saying your answer. So if you, Zach, phoned up Rosie and said, Rosie, I'm doing question 12. What do you get? I want to check it. And Rosie will tell you what she got, and you'll say, that's nothing like mine. Well, it won't be because her data and your data are different, right? So it doesn't lend itself for you to do that, which is good news in tests. Not that you would ever cheat, but if you tried to use someone else's numbers in a test, you'd find you were just wrong. Right now, this guy here, I'll make this bigger. Good. Is called a back-to-back stem and leaf. What this data is, it's archaeological data. It's collected from some site. And in archaeology, the depth, that's how far below the surface at which you find things, is very often important, because what that can tell you if you do it well, isn't things deeper down older than things higher up. And the logic is, if I dropped a coin, right, and 2,000 years somebody else dropped another coin, wouldn't my old coin be really deeper down than the new one because, right, dust and muck accumulates, right? That's kind of the argument. So if you ever watch them, and I actually like these programs, don't they talk about the layer? This was found on the 1700 layer, right? Things that you find in this level were probably dumped there in the 1700s. And they know that because they find a piece of pottery, and that piece of pottery was only made from, 1701 to 1703 or whatever. And so they know that that's probably when that was, that piece of garbage was deposited. So in this site here, we have two different places called Site 1 and Site 2. And these are, I think these are places where people lived. And these are artifacts. That's just things that people would leave behind, right? So if it was an ancient site, couldn't these be things like arrowheads and stone tools, or bones that have clearly been broken or fire has been used on, right? Artifacts could be anything, right? Piece of hide that was cut into a square, right? Anything like that. And this is what the pattern looked like. Now in Site 1, you see 35 and 30, right? And 50 and 55. You see these different artifacts, right? Numbers of them. Now, when you look at the one on the left and the one on the right, I could tell you right off the top of my head, would you agree that Site 1 was used throughout the entire time period? Wasn't Site 2 used in the early time period, and then they just abandoned it, and then they came back again to the same place and inhabited it again? So if this was someplace in Greece, couldn't you say, oh, this city was being used all the time? This city was being used, and then everybody abandoned it, and then they came back, whatever it was, 100 years later, and started using, rebuilding. Now, they can ask questions like the depth. So what is the least and greatest depth of artifact finds? Well, the least depth was 25 in this case. Now, how do I know it's 25, right? 2, 5, doesn't that mean 25? That thing up there is what we call the key, right? What's the greatest depth? Wouldn't it be this number here, 0? And this would be 1, 1, 0. And then Site 2, would you agree it's also at this point here, but I forgot to put in a 2 there. There we go. 20. And what's the greatest depth? 125. And if we look at this data, would you agree that this particular data here was fairly symmetric? What, in roughly middle in the 7s? So I would pick that. How would you describe Site 2? So let's see what the choices are. I would not pick any of those. So I'm going to have to pick from what they've got. Fairly uniform? I have no idea. Okay, I'll go for fairly uniform. Where's the middle? About 8, 7, 9. What's 9? 9. I'm going to argue with this guy. Okay. For number 2, I'm doing fairly symmetric, centered at 90. Thankfully, there's 4 guesses, so you're going to get it right eventually. They think it's fairly symmetric, centered near 90, and I think it's fairly uniform. Oh, no, they say it's fairly uniform, except for a gap. Moral of that story, shouldn't you read the whole sentence? Would you agree that it's fairly symmetric except a gap? It mentions a gap. That's fine. I'm happy with that now. And that is the end of that section. And we're still going to continue, of course, to the next one. Any questions about that? In a lot of those questions, didn't it take me much longer to read it than it did to do it? For quite a few of them. So we are now moving on to our new chapter. We're finished chapter 2. And let's set this up. We're now going to do chapter 3, or at least one of the topics from chapter 3. And the one we're going to do is mean, mode, and median. And so I'm going to do some notes first, and then we'll worry about the homework questions that come after that. These 3 measurements, these are 3 statistics. They are. They're a single number. That represents a typical person in the data. So you would probably use the word average, because that's the most likely one that you've got. Do you know how you might say, well, I did 10 tests, but my average was 80, right? Wouldn't that be a single number that kind of accumulates all the data and says, run about the middle score I got was about 80, right? Sometimes I got 70s and 60s, and sometimes I get 90, and once I got 100, but my average, right, is that. And we call all 3 of these averages. The one that you typically use, its real name is the mean. So let's give you some data and show you how that works. Suppose we collected data on the number of children in your family. In fact, let's do that. I'm going to stop sharing for a minute. We are going to collect data on 2, 4, 6, 8, 9, 10 people, hopefully. If you do not need to answer this data if you choose not to, and that's totally okay. So if there's only you in the family, right? You're a 1-child family, stick your hand up and I'll count you. Rosie, you poor thing. No brothers or sisters. Okay. Now, you and a brother, you and a sister. How many are in a family of 2? How many in a family of 3? Okay. How many in a family of 4? Okay. How many in a, oh, another one. How many in a family of 5? Okay. How many in a family of 6? 7? 8? 9? Me? 10? I like mine. So, oh, some of you may have put it in the chat. Okay, so this is the data from those. Oh, somebody said they forgot, so I'll put it in. There we go, fine. So I'm going to use this data, and somebody else just said 2, so I'll add you in a second. Right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 data points. That's good. Now we're going to calculate the mean, the mode, and the median using this data set. So what's the typical number of people in your family in this class? So to get the mean, you add up all the numbers and 1, 2, 3, 4, 5, 6, 7, 8, 9, and you divide by how many. So I should be able to do it in my head. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 25, 35. And we got 35 out of 9, which is darn close to being 36. So it's about 3.9. Can you trust me? To 1 decimal place. So to get the mean, you have the mode. Isn't that the one you probably would have called the average, right? But its real name is the mean, at least in statistics. Now, we've got another guy called the mode. And the mode is the most popular answer. And if I look at this, weren't there more people who said there was 4 in their family than any other number, right? So the mode in this case would be 4, which, by the way, is pretty close to 3.9. Would you agree? And then the third one is called the median. And the median is the middle number when the data is in order. Well, let's see. There are 9 numbers here. So if I was picking the person in the middle, wouldn't it be person number 5? Let's check that. 1, 2, 3, 4, you. Now, if I counted it from this side, 1, 2, 3, 4, still you. Would you agree that that person there is exactly in the middle of our list from smallest to biggest? And in that case, the answer we got was 4. Have you noticed that all 3 measurements of a typical person from this class, in this particular example, were pretty much the same answer, weren't they? All 3.9 or 4. That is not always the case, right? You could have a data set where there's wild discrepancies between these, right? And that sometimes is very interesting. I want you to pretend that I only changed one number, and that was the 10 that I came from, and it was 30. I don't know what the world record is, but it's probably 30. Isn't there at least one family in the world where there's 30 kids? There's probably even bigger than that, right? But let's pretend whoever that person was, one of them was in our class, and it's now 30. This is the before. And this is going to be after that one change. Now, I'll write down who we have. We have a mean, we have a mode, and we have a median. Now, that one guy, right, this guy here, he is called an outlier. Would you agree that's significantly different from the rest of the data, right? 10 is pretty close to being an outlier, but that definitely is. Now, the before had a 3.9, that was a 4, and that was a 4. Let's see what the changes, if there are going to be any, would be in the afters. So I have a mean, I'm going to have a mode, and I'm going to calculate a median. Before I do any calculations, do you think the mean is still going to be 3.9? Do you think it's going to be bigger than that or less than that? What do you think's more likely if that 10 had been 30? What do you think's going to happen?
It's going to be bigger.
I agree. 30, 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 21, 26, 56. 56 divided by 9. It's now 6.2. Would you agree it's almost doubled in size? What about the mode? Is the most popular answer still going to be 4? Yeah. Doesn't that mean that the mode doesn't get affected by an outlier, right? If your data has one outlier in it, won't the mode be the same with or without it, right? There won't be any significant change. Now, what about the median? Will the middle number still be that 4? Yes. Would you agree that if you change that number to 3 million or back to 10, isn't the middle number still the middle number and it's still 4? What this is trying to show you is the effect of an outlier. Don't outliers only affect the value of a mean? They don't affect what the number for the mode is and the number for the median is. The mode actually, after, who knows, after a few minutes from now, we're probably going to ignore it. The mode is not really very effective. It's not a very useful measure of the typical person. So we're probably going to let it quietly, move into the next room and we'll not look at it anymore. We are going to focus on means and medians, right? Most government data, when they tell you the typical number, right, the average, they use the median and not the mean. So they will tell you the median income for people in Bremerton, right? The median age of the population of Texas, right? The median house values, right? Take an example, median house values. Isn't that the price of a house right in the middle, right? If you took all the houses in a street and figured out what they were worth, wouldn't the one in the middle be called the median? Wouldn't that be the one that they would use for all sorts of purposes to tell you how expensive the houses are? Because wouldn't you just need to have one ridiculously big 4 million mansion that's got a great view next to the water to screw up your average? Wouldn't your mean be really big because one of your houses was 4 million, even if all the others were selling at 200,000? Do you see how that guy causes a problem? So we typically do not use means if we think there's a strong likelihood that there could be an outlier that distorts our data. So that's why the government just basically uses medians all the time. And they're very effective. And they tell you the typical person in the group. You feel comfortable about that? Now, doing it for small data sets is not that big a job. Would you agree if there's only 8 or 9 numbers, can't you do it in the calculator? Sorry, do it in your head, stroke calculator. But when the data gets really big, like 20 numbers or so, wouldn't it be really difficult to do the median, for instance? Because wouldn't you have to rewrite the numbers in order? Because the chances are they're all jumbled up. And then once you've rewritten them, then you have to figure the guy in the middle. So wouldn't it be nice if we could do the same thing, but on our calculator? Right? So I'm going to show you how you can do it on the calculator. And they also have the ability that you can do it on, sometimes you can even do it using salt. Are you all looking at a calculator emulator right now? Right. I think that'll make it a little bit easier for the guys I'm pointing at. Can I make this calculator bigger? No. Can I at least have it with detached keyboard? Whoa, let's not do detached keyboard. That was a bad idea. Let's do it keyboard history. There. I can do that at least. So you're going to see here the keys I press. So I would like to do the same question that we just did by hand, just to show you how you can do it on your calculator, right? So the first thing you're going to do is you're going to find a button. You see it here called stats. Press stats. And you notice it's on edit. Choice number 1, edit. Press enter. And then you take your data and you just basically type it in. So this is me just repeating the data I had before. 1, 2 2s, 2, 2, a 3, a lot of 4s, a 5 and a 10. And that's it. You've got all your data in, right? And it doesn't need to be in order. See if the numbers in your question are all jumbled up, right? It was, 4 1 0 3 2 7 7, all that kind of. Just type them in the order that you read them. Don't even make them in order. That saves you some time. Once you've got your data in, hit the start button again. And now we're going to go to this menu called Calc. And you do it by hitting this button here, Calc. And we're going to go on a guy called One Variable Statistics. And I'm going to hit enter. Now, if you've got a modern TI-84, you'll be seeing what I'm saying, right? And if you are seeing what I'm saying, you then just press the list L1, enter, frequency, enter, calculate. So you just hit enter a lot of times. And all the kind of numbers that we were looking at are in this, and lots of other numbers that you don't need right now, but you might want to use in the future. So let's look at the guy that we call the mean. Do you see the top row there? I don't know if I can make that any better than it is. It looks like an X with a little line above it. Do you see the top row? That's your mean. That's 3.9. I rounded it off, but 3.9. Now, if you scroll down the way by using this, do you see the median is 4? And the calculator won't do the mode for you because nobody does the mode really, right? Now, are we cool with that? Now, sometimes you get questions that say, get the answer, and we just did, right? It was what, 3.94, right? And then it says, change one of your numbers, as I did, and make it 30. So all you do, you scroll down to where it is and you just retype 30. And isn't this going to be the after data? So shouldn't it be 6.2 and 4 again, right? Let's see if it works. Start button, calc, one variable statistic, enter, 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 enter. And isn't it now? Okay, I probably didn't count right. 6.1, I rounded off to 6.2, but it worked. So you can use your calculator to get means and medians. And if the data was like 30 numbers, wouldn't that be really helpful, especially for the median, right? Because you wouldn't need to put them in order. You just type in 30 numbers and then you can go to this menu. Any questions about how you get the calculator, the TI-84 to work? Okay. Now, if you don't have a modern calculator, you're going to have a little tweak to what I just did. So I'm going to show you a kind of abbreviated version of that same type of question, but using an older TI-84. In other words, the one I've got, right? So you hit start, just like we did, edit. I've used this in other questions, so I'm just going to hit delete to get rid of them. It's going to start off the same way, put in the numbers, just like we did before. There's the numbers. You hit the start button, just like before. You move over to calc, you do one variable stats. Now, when I hit this, you won't get that nice little menu we saw. You'll see this, a little flashing cursor, and you're thinking, what the heck's that? Well, this calculator doesn't know where the data is. You have to tell it. And the data was in a thing called L1. So you do blue button, number 1, and that gets you L1. And then you just hit enter, and everybody is there. Right, so you see a little kink at the end. You just have to do blue button 1 to tell it you've put your data in L1. Now, show you why that might be important. Do you see all my data is in L1? Can you imagine that for some reason I want to keep those numbers because I might want to use them in a later question, and I have a whole load of numbers in my second question? Right, there we go. When I'm doing my stats and I want to calculate a one variable statistic, this time maybe I want to get the numbers from L2. You see, all I do is that, and then I press enter. And you see that would have been the mean and so on for my second set of data. That's about the only time in the world I can think of wanting to use L1 and L2. Most people just use L1, rub out the old stuff and put new stuff in when you have a new question. How are we doing, guys? So far, so good? Right. We're now going to look at what happens to data, i.e. these three things, when you do transformations of data. Okay, now I'm going to just rewrite our numbers again. Back to that one, right? And I'm going to use that symbol now to mean mean. And we know the mean was 3.9. And we have a median, which I'm just going to call MED for short, which was 4. And I'm not even going to bother with the mode, right? Mode has went into the next room. We're ignoring modes. So we're only going to focus on mean and median. Now, for my first situation, you add 5 to all the data. So that becomes 6, that becomes 7, that becomes 7, that becomes 9, that becomes 10, and that guy becomes 15, right? So the transformation to my data is that you add 5 to all of it, right? Whatever a transformation is, you do it to all the numbers, right? You don't just do it to one number, you do it to everybody. I do not need to go near my calculator to tell you what the new mean and the new median would be. What do you think the new mean would be if you added 5 to all this data set? What would the new mean be?
It'd be 8.9.
And what about the new median? You're correct.
9.
If I go into your head, Zach, did you just say to yourself, you just add 5 to everybody? Would that make sense? That's all you do, right?
Yep.
None too weird, right? Now, certain transformations, that's exactly it. Suppose I took 2 away from everybody. I'm not going to do this one, but if I subtracted 2 from everybody, wouldn't the mean now be 1.9 and the median would become 2? Now, how about this situation? You treble all the data. So what would the new mean be and the new median be if you trebled all the data? And don't make life hard for yourself.
What does a treble mean?
Oh, treble. Oh, maybe a British word. Multiply by 3. Double, treble, quadruple.
Oh,
right?
Oh, like triple?
triple.
Okay, Americans. Triple for you, treble for me. Okay.
Okay, gotcha.
So, triple with an I to keep the Americans happy. What would happen to your data? Now everybody's forgot the question because of that. What would happen if you multiplied all your data by 3?
You get 26.7 and 27.
And I think you've took this data and multiplied it by 3. We're returning back to this number, and I should have been clearer.
Oh, yeah, so you just multiply by 3.
Okay. So 3 times 4 gets you 12. So, and 3 times that guy gets you 9 and 10, 11.7. So if you add things to your data and you do it to all of them, don't you add the same number to your mean and median? If you subtract a certain number from all your data, don't you subtract the same number from your mean and median? If you multiply all your data by 2 or 3 or 22, don't you just multiply your mean and median by the same amount? So there's only one last situation that we need to concern ourselves with, would be this one. You do call it double and not dibble, right? Okay, so you double your data. Then you add 7. So again, we are looking at the original data, right? Back to the square one. With this data set and that mean and that standard deviation, what would be the, or how would you get the new mean and the new median if you double your data and then you added 7 to the whatever it was?
Would you just times it by 2 and then add 7 to the answer?
Yep.
14.8?
3.9 times 2, add 7, and you nailed it. 14.8. And what would that be? 8 times 2, wouldn't that just be 15? So what this little experiment, if you'd like to call it an experiment, is doing is it's saying, look, the measurement of the typical guy in the middle, right, the mean and the median in these cases, if you change your data, the mean and median typically get changed the same way, don't they? Right, so if you double all your numbers, your median ends up being double what it used to be, right? If you add 7 to all your numbers, it ends up being you add 7 to it, right? That's essentially what we've got. Now, there are only certain calculations where that is true, and they're very often called linear calculations. That just means adding and subtracting things, multiplying or dividing things, right? Couldn't have said to you, I'm going to half all the data points, right? So make them all, that's 5, that's 2.5. If I'd said half it, wouldn't the mean be half of this number and the median would be half this number, right? So as long as you're only doing those, and they're the only ones we're interested in, you are fine. So far, so good? Right. So let's see what some questions are, what they look like in homework. Oh, they've got some chat. I should check that out. Okay, let's do it. And of course, it's got damn answers again, which I don't want. Right, are you looking at getting started, mean, mode, median? Is that the screen you're saying? Okay, good. Let's make it a little bit bigger so it's a little bit easier for you to read. Right. Which of those averages that we did today represents the middle value?
Median.
Great. Which of those is the most frequent value?
Mode.
Right, that just means the one that happens most often, right? And which of those takes all the values into account, which is not the way I'd phrase it, but that's the way they're going to phrase it.
Mean.
Yeah. I would have said, which of those do you add up all the numbers and divide by how many, but that's their way of phrasing it. Now, we have some little funny labels, right? Little funny symbols, one of which we've seen and one we haven't. Now, when it is a sample, we call it a statistic. And doesn't a statistic use that funny little X with the line above it? Right? That's the mean. Now, when you use the word parameter, isn't the parameter a number that you get from the population? That's the one we haven't told you about. The answer is this one. Do you see that funny little symbol there that looks like a U, but it's a little bit long on one side? It's the Greek letter mu, M-U. M-U, mu for mean. That's the population mean. And this little guy here is a X bar. That's how you read it out loud, X bar. And that's the mean of the sample. So a statistic comes from the mean of a sample, X bar. A parameter comes from the mean of a population, that's mu. And then they give you very small numbers. Would you agree that when there's only 5 or 6 numbers, isn't it easier to do it in your head or just do it, you know, by hand than going through all the steps on the calculator? But in this question here, would you agree that the mode was 2? If I wanted to get the mean, wouldn't I just add them all up and divide by 6? So I should be able to do that in my head. That's 11, 17, 18, 19. Check that again, 11, 17, 19, 26, 29. 29 divided by 6 better be a nice number. I think it is. Yep. Oh, God in himmel, it's not. Okay. To one decimal place, it's 4.8. Now, if you wanted to do the median, wouldn't you have to put those numbers in order and then pick the middle one? I think I can do that in my head. Does anybody want to tell me if you put those numbers in order, what would, okay, I think I better write this down. It's too visual. We are going to get the median out of 6 numbers, and something weird is happening. I'm rewriting the numbers in order. There was a 2, and then there was a number 2 again. Then there was a 3, then there was a 5, then there was a 6, and finally there was a 9. And you might think, what's the problem? Watch, I want to pick the guy in the middle. Well, if I pick the guy in the middle, isn't it this guy? And I guess if I pick the guy in the middle, isn't this guy? Would you agree that there's a kind of 2 guys in the middle? Isn't the 3 just as much in the middle as the 5? Doesn't it depend if you're kind of counting from the right or counting from the left? So how do we come up with a single number that represents the median when there's 2 to choose from, like 3 and 5 in this case? How do you
add them together and divide by 2?
Yeah, so the median is 4. when we talk about an average, a mean, a mode, or a median, it's always going to have to be one number, right? You can't have, oh, there's two medians, or there's two means, or there's two modes, right? That's not allowed. You must choose one number. And that's how we get rid of it. Can you imagine a different situation that this happened? And the two numbers in the middle happen to be both 7. It's a bit of a trick question, this. What's the median? Oh, it is a trick question because it's still 7. Would you agree? I mean, adding 2 7s and dividing by 2, yeah, I guess that works, but isn't it pretty obvious it's still 7?
So do you always divide by 2 if there's 3 numbers? Would you divide by 3 or just still?
Oh, you would never. Yeah, you would never get 3 numbers in the middle. Thankfully, you would only either get 1 number in the middle or 2. So if I give you, you might have a data set that looks like this. In this case, would you agree there's only 1 number in the middle? Doesn't that fit? Or you might get a situation where there's 2 numbers in the middle, in which case you add them and half it, which does mean that the median ends up being 8.5, right? And it's okay to have a median of 8.5, right? Isn't it okay to have a mean of 2.1? Right? In fact, the median, or whatever, the mean age of children is 2.1. It doesn't mean you have 2 children and a head. It just means you've got a little bit more than 2 children on average. Are we good with that? Now, just for completeness sake, I want to tell you for our last thing for today, something that could happen with your data set when it comes to the most popular answer, right? The mode. There is a nice simple data set. Would you agree that the most popular answer was the number 3 because there's 2 of them? None weird going on. Do you notice that in this data set, there's a kind of draw in popularity? Now, you don't add those 2 together, 3 add 9 and half it. That you might think you do it, but no, that doesn't work. You don't, or at least you shouldn't, say the modes are 3 and 9, right? Although you will get some textbooks that do that. Bad news, you shouldn't do that. The answer is that there is no mode. Would you agree there is no one number that's more popular than the other? Basically, isn't this data set got 2 numbers? But you might say, well, can't you just get around that? Well, if you said everybody could be a mode, then what about that data set? What's the mode? Didn't get a bit silly now? Wouldn't you say, well, the mode is 1, 3, 5, 7, 7, 8, and 9 because they're all equally popular, right? They all get chosen once. So the rule for modes is if there's one number that's more popular than the rest, you are a mode. If there's a draw between 2 or 3 or all of them, the answer is none. There is no mode. And if WebAssign says otherwise, I'm right and they're wrong. Well, I'm not personally right. A lot of people believe the same as I do, that you shouldn't do it, right? Hopefully there isn't going to be a question where that happens. One mode or there's none at all. And last name, have we done the last name yet? No. Last name for attendance and bye-bye.